2022. So like the sales details are there in the sales table. Our requirement is we want to get year wise, quarter wise sales. Means we want to get like this. In the first column, we want to get year. In the second column, we want to get quarter. Okay, year, then quarter. Okay, then sales. Okay, how much amount collected? Amount. For example, in the 2016, in the first quarter, so and so amount collected. Okay, in the second quarter, so and so amount. In the third quarter, so and so amount. Okay, and in the fourth quarter, so and so amount collected. For example, in the first quarter, 5 lakhs amount collected. In the second quarter, okay, 4 lakhs amount collected. Okay, next, okay, 10 lakhs amount collected. In the third quarter, 10 lakhs amount collected. Okay, and in the fourth quarter, 3 lakhs amount collected. And here we want to get 2016 sales subtotal. Here we want to get. In the same way for 2016 also. Okay, 2017 first quarter sales. 2018 second quarter sales. 2017 second quarter sales. 2017 third quarter sales. 2017 fourth quarter sales. So 2017 sales we want. So finally here we want to get grand total. Grand total we want to get. So 2016 sales plus 2017 sales here we want. Okay, so that is our requirement. So year wise, quarter wise sales we want. So to get like this, see, there is already sales table is there in some other schema. I'm opening that one. Observe. See, there is one table is there, sales table is there. So this is the sales table. Select star from sales. Sales is the table name. In this table, date ID, and on that date, how much amount collected. On 1st January 2015, how much amount collected. On 2nd January 2015, how much amount collected. So like this up to 2017 data is there. Okay. So now our requirement is we want to get year wise within the year quarter wise sales. In the 2016, in the first quarter, what was the sales? So like this we want to get. That is our requirement. So for this, what we write? First we want to get year. First column year. Second column quarter. In this sales table, is there any year column or quarter column? No. But date ID is there. Using this date ID, can we find year value and quarter value? Yes. So find it. Which function we have to use? toChar. So we want to get year. What we have to write? toChar of column name is date ID. Column name is date ID. Date ID, comma, wait. Okay. For this we are giving alias name as year. Next we want to get quarter. So to get quarter, what we have to write? toChar of date ID. Okay. Let me check the column name, please. See. Yes, date ID. So date ID. We want to get quarter number. So Q as quarter. Quarter is alias name. Okay. Next, sales we want to get. Okay. So here amount column is there. So if year value and quarter value is matching, that should be treated as one group. And on that group, we want to apply sum function. So amount we want to, sum of amount we want to calculate. So what we have to write here? Sum function we have to call, column name is amount. So sum of amount. So For this, I'm giving alias name as amount. So from which table we are retrieving here? Sales table. Now group the records according to the year and quarter. So according to the year means what we are writing? To care of date ID comma y. Okay, next to comma. So comma. Next to care of date ID comma Q. So according to the year and quarter, we are grouping the records now. And we want to get that result in the order by. According to the year, we want to get the order by year. So now observe here. I'm copying this. See. See here. So it is giving year wise, within the year, quarter wise sales it is giving. Observe 2015 first quarter sales, 2015 second quarter sales, 2015 third quarter sales, fourth quarter sales. Next 2016 first, second, third, fourth. Next 2017 first, second, third, fourth. I want to avoid repetition of year here. I want to avoid repetition of year. And after 2015, I want to get one length gap. Okay, so for that, what we have tried here? Break on year, skip one. Okay, observe now. So 2015 first quarter sales, second, third, fourth. 2015 sales. 2016 first quarter, second quarter, third, fourth. 2017 first, second, third, fourth. What is happening here? Try to understand. Yeah. Now here. Okay, for this value, what is the year value? 2015. What is the quarter number? 1. For this year value, 15. Quarter number 1. 2015 quarter number 1. Okay. For this 2015 April means which quarter? Second quarter. 2015 second quarter. Okay. So May also second quarter. Okay. June also second quarter. Okay. July third quarter. This is third quarter. So like this, it is finding year value and quarter value. If year value, quarter value same, that will group the records. Because what we have written here, group by year comma quarter we have written. So here we are finding year, here we are finding quarter. Okay. So if year value and quarter value is same, that will be treated as one group. This is 2015 first quarter group. This is 2015 second quarter group. This is 2015 third quarter group. Like this, it groups the records. If year value and quarter value is matching, that will be treated as one group. Okay. So like this, it is finding year wise, quarter wise sales. Now our requirement is, so this is finding, displaying year wise within the year, quarter wise sales. Now our requirement is, we want to calculate this year-wise sales. In the 2015, how much amount collected we want to get here? Subtotal. This value subtotal we want to get. 2016 subtotal we want to get here. And finally we want to get grand total. Okay. According to the year, I want to calculate now. Okay. So display, question is, display year wise within the year, quarter wise, year wise, quarter wise sales. Okay. And calculate subtotals. So calculate year, calculate subtotals and grand total Okay, according to year. So according to the year, we want to calculate now. Means according to the first column, we want to calculate. So which function we have to use? Roll up function we have to use. So in the group by, just we are calling roll up function. So roll up function we are calling. So here first column is year, second column is quarter. So according to the year, it calculates subtotal and grand total. Just observe the output here. Just to the previous query, in the group by, I'm calling roll up function. It displays subtotals and grand total now. It will calculate, observe. See here. Okay, this is 2015 sales value. In the 2015 first quarter, 20,000 amount collected. In the second quarter, 26,000. In the third quarter, 13,000. In the fourth quarter, 18,000. In 2015, total 77,000 amount collected. In the 2016, 24,000 amount collected, subtotal. 2015, subtotal. 2016, subtotal. 2016 sales. 2017 sales. Finally, grand total. In these 3 years, we got this much amount. Okay, next. Now, instead of using, we want to get year-wise, quarter-wise sales, and we want to calculate subtotals and grand total according to year and quarter also. According to year and quarter, both. So which function we have to use now? Cube function. So cube function we are using. So just observe the output here. Just observe the output. See. 2015 sales. 2016 sales. Okay. So next in the 2017 quarter wise and 2017 sales. Observe here. In all those 3 years, first year amount, this much amount collected. First quarter amount. Second quarter amount, this much. In all 3 years, in the first quarters, we got this much amount. In the second quarter, this is the amount. Third quarter, this is the amount. Fourth quarter, this is the amount. Finally, grand total it is displaying. So quarter wise it is displaying. Observe. Okay. So all first quarters, this is first quarter 10,000 plus first quarter 7,000 plus first quarter 20,000. That is this first quarter subtotal value. So like that it is calculating quarter wise, sorry, this one. Quarter wise sales. So quarter wise subtotal. This is grand total. So this is the way of using roll up and cube. Last example. There is a table is there. Person table is there. For example, assume that our Indian government is maintaining all Indian people data. Okay, 130 plus crores data is there in the person table, like person ID is a state, gender, age, Aadhaar card number. So all Indian people data, their Aadhaar card numbers, they are maintaining like this. Our requirement is, okay, here person ID, all states, okay, and their genders, their age value, their Aadhaar card number. So our Indian government is maintaining all states information here. So every person, every Indian data is there. Okay, their Aadhaar card numbers are there in this table. Our requirement is, we want to find state-wise number of people. So we want to find state-wise population of India. State-wise population we want to find now. Okay, observe here. So there is a table. There is sample data is there. like select star from person, some sample data is there in this table. So in the person table, some sample data I have taken and observed. Okay, so see the column headings here: person ID, person name, state, gender, age, and Aadhaar card number. Okay, so sample data we are taking. So generally in the Aadhaar card number, 12 digits will be there. Just sample data I have taken like this. So here Telangana state, males and females data is there. And Gujarat state, males and females data is there. Now our requirement is, I want to find Telangana population. In the Telangana, how many people are there? Telangana population I want to find, and Gujarat population I want to find. Okay, like this, every state population we want to find. So now what we have to do? According to which column we have to group the records now? According to the state. If state value is same, that will be treated as one group. Telangana is one group, Gujarat is one group, Maharashtra is one group, West Bengal is one group, like that. On this group, which function we have to apply now? Which function we have to apply? Count function. We want to find the population, number of people. Number of people means which function we have to use? Count. Count function we have to apply now. So we write like this. Okay, select. Our requirement is, we want to get like this. State, its population. Okay, or number of people. Okay, Telangana state, number of people. Okay, Gujarat state, number of people. Like this we want to get. So for this, what we have tried here? Select first column, state we want. Next, number of people we want. Which function we have to use? Count. Okay, as number of people. Okay, from which table? From person table. From which table? What is the table name? Table name is person here. Table name is person. So from person table, now group the records according to which column? State column. Okay, that's it. Very, very simple. So if state value is same, that will be treated as one group. So this is Telangana group, this is Gujarat group. If state value is same, that will be treated as one group. So state-wise population we are getting. Observe here. See. So Gujarat state population, Telangana state population, it is displaying. So according to this example, see here 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. Gujarat 8. Okay, and Telangana 9 it is given according to this example. So Telangana 9. Okay, so this is state-wise population. Next, our requirement is, we want to find state-wise, within the state gender-wise. In the Telangana, how many number of males are there? In Telangana, how many number of females are there? In the Gujarat, how many number of males are there? How many number of females are there? So like that, state-wise, within the state gender-wise, we want to get. Okay, so display state-wise, within the state, gender-wise, number of people we want to display. This is our requirement. Okay, now we have to group the records according to two columns now. Within the state, gender we want. So group by, which columns we have to take now? Group by state, within the state, gender we want. So group by state, comma, gender. So we write like this. Select, okay, state, comma, gender, number of people we want. So what we write here? Count of star as number of people. From which table? From which table? Person table. Then write group by. We want to group the records according to state, within the state, gender. Okay, observe now. See, So state wise, within the state, gender wise, number of people it is displaying. I want to get this result in the order according to the state. So little bit we are modifying. Order by state. Or you can write 1. Okay, observe now. See here. So Gujarat state, female population. Gujarat state, male population. Telangana state, female population. Telangana state, male population. Like this it is displaying. I want to avoid this repetition. So to avoid repetition, what we have to write? Break. Break on which column? State column. So break on state, skip 1. Okay. So now observe here. So Gujarat state, number of females. Gujarat state, number of males. Telangana state, number of females, number of males. And here we want to get subtotal Gujarat population. And here we want to get subtotal Telangana population. Finally, India population we want to display. Okay, Gujarat state population, Telangana state population. Finally, grand total we want to display. That is our requirement. So to calculate subtotal and grand total according to the state, we want to calculate now. So the same question, a little bit we are changing. So display state wise, gender wise, number of people, and calculate sales state wise population. Okay, calculate state wise population and calculate India population. Calculate state-wise population and calculate India population. That is our requirement. India population means grand total. State-wise population means subtotal. So we need to calculate subtotal. So roll up state comma gender according to the state. So according to the state, it displays. Observe. According to the state, it displays population and in total India population also it is displaying. Observe here. Gujarat female population, male population, total Gujarat population. Okay, Telangana female population, male population, total Gujarat, Telangana population, total India population, grand total. Okay, subtotal, grand total. So now my requirement is, I want to calculate, I want to display state wise within the state, gender wise number of people, and we want to calculate state wise population and calculate India population, and also calculate gender wise population. Gender wise population also we want to find. This is our requirement. So according to gender, we want to calculate the population, and according to the state also we want to calculate the population. So which function we have to use? Cube. So cube function we are using now. Observe. See here. Just a minute. See. So Gujarat state, female population, male population, total Gujarat population. Okay, Telangana state, female population, male population. Okay, total Telangana population. Okay, in India, female population, in India, male population. India female population, India male population. Total India population. So this one we are getting extra with cube function. So cube is finding subtotal according to the gender also. According to the state it is calculating. According to the gender also it is calculating. Finally it is displaying grand total. So these are the examples on roll up and cube. So roll up and cube functions are over. And next chapter, and very important chapter for interview purpose and for real time also. So the topic name is Giants. So Giants is the topic name. So listen carefully. See, database means database contains number of tables. Many tables will be there in the database. In the database, many tables will be there. For example, if we take college database, what college maintains? Like student details, students marks details, their fee details, okay, their college courses details, college staff details. So like this, many tables will be there. If we take bank database, bank has to maintain their customers details. Customer is performing the transactions, the transactions details. So their branches details, okay, their staff details. Okay, so like this, they have to maintain their products details, etc. So every database contains a set of tables. College database contains multiple tables like this: student table, marks table, fee table, course staff, etc. Bank database contains these tables like customer tables, transaction table, branch table, etc. So every database is having multiple tables. Sometimes we need to retrieve the data from multiple tables. To retrieve the data from multiple tables, we have to use one concept. What is that one? Giants. For example, there is a table is there, student table is there. It has fields like student ID, student name, student city, complete student details are there. Okay, here student details are there. There is another table is there, marks table is there. In the marks table, just they are maintaining marks details, marks of subject 1 or math subject marks, physics subject marks, chemistry subject marks, like this they are maintaining. Okay, so 1001 student, 70 marks he got, 80 marks he got in second subject, okay, 50 marks he got in third subject, like this we are maintaining. So now student is one table, marks is another table, student table is having student details, marks table is having marks details. Now this math faculty is asking data like this. He don't want physics marks, chemistry marks. Okay, he does not want physics marks, chemistry marks. Just he wants math subject marks along with student details. Now student details are in which table? Student table. Math marks are in which table? Marks table. So his requirement is, math faculty requirement is, he wants to get data like this: student ID, student name, and math subject marks. Math subject marks. This is math faculty requirement. Okay. For example, principals are there. Principal wants data like this. He wants student ID, student name, okay, math subject marks, physics subject marks, and chemistry subject marks. This is principal requirement. Okay. So now observe here. Student details, SID, SNAME are in which table? Student table. Which table? Marks table. So now from these two tables, we want to retrieve the data now. So in such type of situations, which concept we have to use? Giants concept. So now here SID, SNAME, these columns are in which table? Student table. Math, physics, chemistry, marks are in which table? Marks table. So from these two tables, we want to get the data here. So we have to use Giants concept. So to retrieve data from multiple tables, we use this Giants concept. That's it. So topic name is Giants. What is the general meaning of giant? Giant means connect or link or combine. Okay. So joining, combining, linking. So these are the general meanings. Okay. So This Jan is one operation. What is Jan? Jan is one operation like sorting operation, ascending order and descending order sorting. Like filtering operation, salary greater than 3,000, job equals to manager. Okay, like filtering operation, like sorting operation, Jan is also one operation. So what is Jan means? Jan is an operation like filtering, like sorting. Okay, Jan is also one operation. So Jan is an operation. What it will do? That combines one table records with another based on some condition. This condition is called Jan condition. So Jan means Jan is one operation that combines one table records with another table based on some condition. That condition is called Jan condition. Here this Jan condition plays key role here. This Jan condition decides. This Jan condition decides. Okay, which record in one table, which record in one table should be joined with which record in another table. So this Jan condition decides which record in one table should be joined with which record in another table. See, for example, see here. The same example we are taking. Here student table is there. This is the student table. And this one is the marks table. So this is student table and this one is marks table. Okay. So like this, some students data is there, like 1002. Okay, 1003. Okay, some students data is there like this. Okay, try to understand. I'm explaining with example. See here. So this is the sample data. So these students marks details are there in the marks table. So 1002 student marks, 1003 student marks, 1004 student marks, and 1005 student marks. So now what is our requirement? Our requirement is we want to get student details from student table, mass subject marks from marks table. This is our requirement. SID, SNAME, these columns are in student table. And this mass subject marks are in marks table. From two. For this, we write one Jan condition like this. Observe here, in these two tables, which one is the common column? SID is the common column. Okay. So, student tables SID, I want to compare with marks tables SID. Can I write like this? Okay. Can we write like this? No. Why? Okay. Column name is same. So now Oracle cannot understand which student ID value you are comparing with which student ID. Okay. Oracle cannot understand. Naming ambiguity problem will occur. So naming ambiguity problem is occurring. Ambiguity means confusion. Because of same name, it is getting confusion. Ambiguity means confusion. Same name is there. Because of same name, it is getting confusion. When it is getting confusion, it gives error. So naming ambiguity problem will occur. We cannot write like this. So what we have to do now? This is student tables student ID. This is marks tables student ID. Like that, we have to tell clearly. So what we are writing here? Student dot SID equals to marks dot SID. Like this we write. But here, for our convenience purpose, we are taking these table names as short, small. But tomorrow in the real time, lengthy table names may be there. Okay. So, for example, here this table name is student marks details. Like this lengthy name is there. So every time using this much lengthy name means it becomes complex. It becomes lengthy. So that's why to avoid this problem, it's better to give alias names here. For student table, I'm giving alias name as S. For marks table, I'm giving alias name as M. So now this student table alias name is what? S. Marks table alias name is what? M. Instead of writing student.sid, we can write s.sid. Instead of writing marks.sid, we can write m.sid. So this is called Jan condition. So this Jan condition decides which table in one record should be joined with which table in another record. So this condition we are calling as the Jan condition now. This Jan condition decides which table in joined with which table in another record. So observe here, what is first student ID value here? Okay, observe carefully here. See, what is this first student ID value? 1001. 1001. Is 1001 S.SID value is what now? 1001. Okay. So M.SID value is what now? M.SID value is what now? 1001 here also. Is 1001, 1001 both are matching? Yes. So student ID in student table and student ID in marks table both are matching or not? Matching. So it combines this record with, it combines this 1001 record with this 1001. This is janning. Jan means combining. Okay. So what is the benefit we are getting? If we jan like this, you can access math marks now, physics marks now, chemistry marks now. That is the advantage. Okay. Here if 1001 is matching with 1001, perform jan operation here. Because of janning, you can access math marks, physics marks, chemistry marks. Logically from here to here, it reads as one table. Okay. Now from here to here, it reads as one record. Logically, you can understand like this. So logically from here to here, it reads as one table, and logically after performing jan operation from here to here, one record. Okay. So this 1001 record joined with this 1001. So because of joining like this, we can access math subject marks, physics subject marks, chemistry subject marks. So now this 1001 person name is A. He got how many marks in maths? 70. So here we get like this. 1001 A student got 70 marks. Like this we can access. Okay, not only maths marks, physics also we can access, chemistry also we can access. Next, this 1001 value. Student ID is 1001. Is it matching with 1002? No. Is it matching with 1003? No. Is it matching with 1004? No. 1005? No. So first record condition checking is over. Next it takes second record. Second record value is what? 1002. Is 1002 matching with 1001? No. Is 1002 matching with 1001? Is 1002 matching with 1001? No. Is 1002 matching with 1002? Yes. Now it performs the join operation. This 1002 record will be joined with 1002. Okay. Next 1002 not matching with 1003, 1004, 1005. It will not perform join operation. Next here 1003 is there. Is 1003 matching with 1001? No. Is 1003 matching with 1002? No. So is 1003 matching with 1003? Yes. So it performs join operation now. 1003 record will be joined with 1003 record will be joined with 1003. Okay. So next 1003 not matching with 1004, 1005. Next 1004. Is it matching with 1001? No. 1002? No. 1003? No. 1004 matching. Jan. Okay. Is 1004 matching with 1005? No. 1005. Is it matching with 1001? No. 1002? No. 1003? No. 1004? No. 1005? Yes. Perform Jan out. So student table record joined with marks table record. Student table record joined with marks table record based on some condition. This condition we are calling as the join condition. So this is the concept of joins. So now by combining like this, now we can access the student details along with marks details. From multiple tables we can retrieve the data. Okay, now see here. See. So Jan purpose is combining one table records with another based on some Jan condition. So after performing this Jan operation, we can retrieve data from multiple tables. Okay. So from multiple tables, we can retrieve the data. So that is the purpose of Jan concept. So the Jan's concept main goal is retrieving data from multiple tables. I'm writing below here. So Jan is an operation that combines one table records with another based on some condition. Just now we have seen. According to this example, this is the Jan condition. Okay. So this Jan condition is performing Jan operation here. After performing Jan operation, we can access data from multiple tables. So this Jan's concept is used to retrieve the data from multiple tables. If you want to retrieve the data from multiple tables, we use this Jan's concept. So that is the purpose of Jan's. Okay. So now, see here, there are different types of Jans are there. First one is equijan. This equijan can be also called as inner Jan. Okay. Second one is outer Jan. In the outer Jan, some subtypes are there, like left outer Jan, right outer Jan, and full outer Jan. So left outer Jan, right outer Jan, and full outer Jan. Okay. Now, next third one is non-equijan. And fourth one is self-Jan. And last one is cross-Jan. This cross-Jan can be also called as product Jan, or you can say Cartesian Jan. So these are the types of Jans. Equijan, or you can say inner Jan, outer Jan. The outer Jan subtypes are there, like left outer Jan, right outer Jan, full outer Jan. Next, non-equijan, self-Jan, cross-Jan. Okay. So just now we discussed that Jan is one operation. Okay. So just now we discussed that Jan is one operation. This operation will be performed based on Jan condition. So here this Jan condition decides which record in one table should be Janned with which record in another table. Okay. So Natural Jan is not that much important. Natural Jan is also equi-Jan only. Equi-Jan without duplicate columns is natural Jan. Natural Jan also equi-Jan only. Okay. See. Equi-Jan. Or you can say inner Jan. See. If Jan operation is performed, based on equality condition, if Jan operation is performed based on equality condition, then it is called equi-Jan. If Jan operation is performed based on equality condition, then that is called equi-Jan. Just now we have seen one example. In this example, here, which condition we are using? Equality condition only we are using. So here this Jan operation, if this student table student ID matching with marks table student ID, if both are matching, both are equal, it is performing Jan operation. It is janning this record with this record. So this is equi-Jan only. Based on the equality condition, if it performs Jan operation, that is a equi-Jan. Okay. So if condition is true, it gives the records. Means it gives matched records. If condition is true, it gives the records. Okay. So see one example on equi-Jan. There is one table is there. EMP table is there. EMP table is having fields like employee number, employee name, okay, job, salary, department number, etc. Okay, and there is one more table is there. Department table is there. I'm taking sample data here. Okay, see. See here. So this is EMP table data. EMP table data and department table data, sample data I'm taking. Observe. So see. This is EMP table data and this one is department table data. So EMP table is having fields like employee number, employee name, salary, department number, etc. Employee details are there. In the department table, department number, department name, location, these columns are there. So employee details are there in the employee table. Department details are there in the department table. Our requirement is we want to get employee details along with this department details. Employee details are in employee table. But department details are not here in the employee table, just a department number is there. Whereas department details are there in the department table. Okay, our requirement is what? From employee table, we want to get employee name and salary. These are employee details. And from department table, I want to get department names and location. So this is my requirement. So now observe here, e-name, salary, these two columns are in which table? EMP table. E name, salary are in EMP table. This D name, location, these are in which table? Department table. So from two tables, this E name, salary are in employee table, D name, location are in department table. So from two tables, we want to retrieve the data. From multiple tables, if we want to retrieve the data, which concept we have to use? JAX. So now, in these two tables, is there any common column? Department number is a common column. Okay. So now, can we write like this? Department number equals to department number. Can we write like this? No. Why? Okay. Because now Oracle will get confused which department number that has to compare with which department. So here column name is same. So you cannot use like this. We must use table name. Okay. So to make table name short, we are giving alias name. For EMP table, we are giving alias name as E. For department table, we are giving alias name as D. So employee table department number, we want to compare with the department table's department number. So what we are writing here? E dot department number equals to D dot department number. So if this department number is matching with the department table's department number, that will perform join operation. So now A employee is working in research department. 20/20 matching. B employee is working in research department. Okay, so 30/30 matching. 1003 C person working in sales department, like this. So we need to perform join operation if this E dot department number value equals to D dot department number value. Okay, so which columns we want to retrieve, we have to tell here. Which columns we want? Employee name, salary, department name, location. So select, observe here, I'm writing like this. Select first column, employee name we want, comma, salary we want, then department name we want, then location we want. From which tables? From two tables. One is EMP table, another one is department table. So we write like this. So select E name, salary, department name, location. So E name, salary, department name, location. Four columns we are taking. E name, salary are the columns of EMP table. D name, location are the columns of department table. From two tables we are retrieving. So from EMP comma department we are writing. Okay, then write the join condition here. Where EMP dot department number. Can we write department number equals to department number? No, we cannot write like this, because now it will get confused which table department number you are comparing with which table department number. Naming ambiguity problem will occur. To avoid that problem, clearly we are telling that EMP table department number compare with department table's department number. So like this we are writing. Okay. See, I'm copying this. So what is happening? Just observe. Here I'm opening our batch schema. Our batch schema is batch 2 PM. Okay. So here there is no department table is available. Till now we didn't create any department table. So department table is not available. So in the Google Classroom, I already provided one sample tables file to you. So in this, there is department table is available. So creating department table queries there, and inserting records into department table, 4 queries are there. I'm copying all these queries. So now, to save this table data, we are writing commit. Open department table data here. Select star from department. So how many records are there? 4. 10th department, accounting department located in New York. 20 research department located in Dallas. So like this, department details are there. And employee details are there in the EMP table. Employee details are there in the EMP table. Here, employee details are there in the EMP table. Department details are in the department table. Our requirement is we want to get this employee name and salary and department name and location. So EMP table is having just a department number only. No department names. But we want to get department details also. Employee details along with department details. So we are writing query like this. Select ename, salary, EMP table columns, dname, location, department table columns. From EMP, department, two tables we are retrieving. Where joining condition we are writing. If EMP table department number value matching with department table department number value, then join. Okay, observe now what it is giving. Just observe. It gives employee details along with department details. See here. So check here. So Smith employee data we are checking. Smith is the employee. He is working in which department? Department number is 20. So Smith is working in department number 20. So department number 20 name is what? Research, located in the Dallas. Okay, observe here. Smith, first employee Smith. Smith is working in 20 department research, located in the Dallas. So EMP table data and a department table data joined here, and it is giving like this. Next, some more examples. Observe here, Allen and Ward. Next records, Allen and Ward. Allen and Ward are working in 30 department, sales department. See, Allen and Ward both are working in 30 department. 30 is the sales department. Sales department. Now see here, Allen and Ward are working in sales department located in the Chicago. So we got correct answer. So we got employee details along with the department details. But the problem here is this query gets executed slower. Okay. So this query gets executed slower than this query which I am writing. For this EMP table, I am giving alias name as E. So beside of table name, write one more name that becomes alias name. Okay. Beside of table name, write one more name that becomes alias name. Don't use any as keyword here. For column alias, we use as. For table alias, don't use as. Beside of table name, give another name that becomes table alias name. For EMP table, we are giving alias name as E. For department table, we are giving alias name as D. So here, this query takes some time for execution because this ename column is in which table we are not telling here. So is this now when this query is executed, it has to search for ename column in EMP table as well as in the department table, in both tables. So in which table this ename column is there, we are not telling. The salary column, in which table salary column is there, that has to search here. In which table dname column is there, that has to search here. Today we are working with 2 tables. Tomorrow we may want to work with 5 tables. So in all 5 tables, that has to search for the column. So automatically some performance will be degraded. So because of that reason, so we are telling like this. So E.ename. E.ename means what? Employee tables ename. E means what? Alias name of EMP. E is the alias name of EMP. So here you are telling that ename column is in the EMP table. EMP table's ename column. Directly it goes to EMP table, picks ename. So it gets executed faster than this one. Next, E.salary. Next, dname. In which table? Department table. So D.dname, D.location. So like this we write. So if we write like this, is it executing or not? Executing. but performance will be degraded. To improve the performance, we are giving table aliases, and those alias names we are using. Okay. So without giving alias names also we can write like this. EMP dot we can write. But if table name is lengthy, employee details. Like this, if lengthy name is there, every time you need to write lengthy name. To make table name short, we are using alias name. Alias name makes table name short. So this is the query. Same result it is giving. Observe. So same result it is giving. Sorry. Just a minute. Here, because of we are giving alias names, here also we have to use alias names only. Okay. So here, because of we are giving alias names in the where class, we have to use those alias names only. Okay. So I'm copying this. See here. It is giving employee details along with department details. So Smith is working in research department, Allen and Ward are working in sales department. Same result it is giving. So just to the previous query, this query difference is we are giving alias names. We are using alias names. Okay, so what is happening here? Just observe here. This is the sample data. It is comparing. What is the Jan condition we have written here? E dot department number equals to D dot department number. So based on this Jan condition, it performs the Jan operation. Later it selects the data. So now observe. Okay, this one is department number is 20. Is 20 matching with 10? No. Is 20 matching with 20? Yes. It performs a Jan operation now. 20 record will be janned with 20. If janning like this, what is the advantage we are getting? We can access department name and location. So now this 1001 employee A is working in which department? Research department located in the Dallas. Okay, next value 20. Is 20 matching with 10? No. Is 20 matching with 20? Yes. So it performs Jan operation here. So this 1002B record will be janned with 20. He is also working in research department. So next value 30. Is 30 matching with 10? 20? No. 30? Yes. So performs Jan operation now. So this 1003 C30 department will be janned with this 30. So he is working in sales department. So 30 not matching with 40. It will not jan. Next 10. Next one is 10. Is 10 matching with 10? Yes. So 1004D will be janned with 10. Okay. Next 10 is not matching with 20, 30, 40. It will not perform Jan operation. Next 1005, 10. 10 is matching with 10. It performs Jan operation working in accounts department. Okay, 10 is not matching with 20, 30, 40. Next 1006, F, 30. 30 not matching with 10, 30 not matching with 20, 30 is matching with 30. Sales department. So like this, it is performing Jan operation. After performing Jan operation, data will be selected now. So now logically, from here to here, this will be treated as one table. And from here to here, this will be treated as one row. From here to here, this will be treated as one row. So that's why it is selecting department name and location. So this is the concept of JANs. So 1001 A employee is working in research department. 1002 B is working in research department. Like this, we are getting the data after writing this query. See, listen carefully. So this Jan query can be written in two styles. This Jan query can be written in two styles. What are those? One is Oracle style, or you can say native style. Oracle style, or you can say native style. And second one is ANSI style. So among these, which one is the best way, sir? This second one is the best way. So among these two, Oracle style is possible and ANSI style is also possible. Among these, ANSI style is the best way. This ANSI style is best way. Why, sir? So if anything is following ANSI style, means portability feature we will get. Okay, so the Jan query written in Oracle, you can run in SQL Server or MySQL in some other relational database management softwares you can run. So portability feature we will get. So that's why ANSI style is the best way. Why? Because portability feature we will get. It is portable. And whereas this Oracle style, it may not give guarantee. It may be portable or it may not be portable. It cannot give guarantee. We cannot say this Oracle style we can run in remaining relational database management softwares. So we cannot give guarantee here. But whereas ANSI style it is following means we can give guarantee. Okay, so the Jan query which is written in ANSI style in Oracle, if we are writing that we can run in any other relational database management software. So it's better to follow ANSI style. I explained both. So just now we have seen this query. This is the EquiJan. Okay. So here understanding the question is important. The question is display the employee details along with department details. This is the question. So we want to display the employee details along with department details. So for this, we are writing this query. Just now we have written. Now this is which style, sir? This is Oracle style. So then what about ANSI style? In ANSI style, we have to follow two rules. See here. In Oracle style, to separate two tables, we use comma. Observe here. Here EMP is one table. Department is another table. To separate these two table names, what we are using here? Comma. To separate two table names, we are using comma. To separate two table names, if we are using style, Oracle style, or you can say native style. So in Oracle style, to separate two tables, we use comma. We use comma. Comma we use. Whereas in ANSI style, okay. So in ANSI style, to separate two tables, we use keyword. To separate two tables, we use keyword here. In ANSI style, we use keyword. Some keyword we use. Like for EquiJan, inner Jan keyword. For left outer Jan keyword. For right outer Jan keyword. For cross Jan keyword. Like that, some keyword we use in ANSI style. Whereas in Oracle style, to separate two tables, just we write comma. Whereas in ANSI style, to separate two tables, we use one keyword here. Okay. And one more difference is in Oracle style, we write Jan condition in where clause. In where clause. Whereas in ANSI style, we write Jan condition in on clause or using clause. On clause or using clause. In on clause or using clause, we write the Jan condition. So these, if you remember these 2 points, easily you can write this Jan query in 2 styles. Very, very easy. So just observe these points. Okay. So in Oracle style, to separate two tables, what we use? Comma. In ANSI style, to separate two tables, we use keyword. In Oracle style, we write Jan condition in where clause. In ANSI style, we write Jan condition in on clause or using clause. If you remember these points, easily you can write. Observe. So now this is the Oracle style. The same query we want to write in ANSI style. So we are writing like this. The same query. Okay, we want to get employee name, salary, department name, location. So same list we are giving. To separate two tables, to separate two table names, instead of writing comma, what we have to write? Keyword. For equijan, we use one keyword. What is that one? Inner jan. Inner jan keyword we have to use. And this is jan condition, right? This jan condition, instead of writing in where clause, wait, we have to write on clause. Like this we can write. Okay. Then the same query. This is ANSI style. In the ANSI style, this jan condition we can write in on clause or using clause. So among these, which one is best way? Means on clause is the best way. This on clause is the best way. Okay, why sir? Why on clause is the best way? See here. So here in the on clause, we are specifying jan condition here. The same query I am writing. The same query I am writing here. But instead of using on clause, I am using clause. So when we are using clause, okay, now in the EMP table, what? In the EMP table and in the department table, what is the common column here? Department number. In the EMP table, this department number column name is what? DPTNO. Here also DPTNO. So common column name is same here. So because of common column name is same, here you have no need to write department number for two times. Just simply write department number. But the problem here is, okay, let me explain why this one is best, sir. For our convenience purpose, so E dot department number is equals to D dot department number. Like this writing joining condition means it is becoming lengthy. So to make it short, we are using column name. We are giving only once. Okay, this is the only flexibility we are getting. For our convenience purpose, we are writing using department number. Implicitly, this will be converted to on E dot department number equals to D dot department number. So using class will be converted to on class implicitly by the Oracle. So here conversion is required. So it takes some time for conversion. So that's why this is the best way. So it gets executed faster. Here conversion is not required. Here conversion is required. And one more point is, if we want to using common column name must be same. Okay. For using common column must be same. For using class, common column name must be same. If common column name is different, it is not possible. Common column name must be same here. For example, in the EMP table, this column name is, in the EMP table, this column name is department number. In the department table, this column name is DNO. Now, can I write like this using department number? Can I write like this? No. Here, this column name is department number. No, this is DPTNO is not there in the department table. So now, internally, it cannot, it is unable to write the perfect Jan condition here. That's why common column name must be same. Okay. So now I'm running this ANSI style. Observe. So two points are important here. To separate two table names, we are using one keyword. And this Jan condition we write in on class or using class. Best way is on class. Okay. So I'm copying this. Observe. So using on class, we are displaying employee details along with department details. Observe here. So Smith is working in research department. Alan Ward are working in sales department. Okay. So here we are using ANSI style. In the ANSI style, in the on class, we are writing joining condition. The same query I am writing by using class. So here using class we are using. See here. So it is also giving same result. Smith, Allen, Ward. Okay, Smith is working in research, Allen, Ward are working in sales. Okay. So with this you can understand that ANSI style we can write by using on class or using class. If you want to use using class, common column name must be same. This using will be implicitly converted to the on class only. So this is about equijan. Okay. So if anyone is asking what is the purpose of Jans, means simply you can say this Jans concept is used to retrieve the data from multiple tables. To retrieve the data from multiple tables, we are using it. So the general meaning of Jan is, Jan means combine, connect. One table record will be connected with another table. EMP table record will be connected with department table. One table record will be combined with another table record based on some condition. That condition we are calling as the Jan condition. This Jan condition is deciding which record in one table should be jammed with which record in another table. So these are the types of Jans. Among this, very clearly we discussed about equijan. This Jan query we can write in two styles. One is Oracle style, another one is ANSI style. Among these two styles, which one is the best style? ANSI style is the best style because we portability feature here. If we write Jan query in ANSI style, okay, that we can run in other relational database management softwares like SQL Server, MySQL, etc. Whereas if you write in this Oracle style, we cannot give guarantee. It is portable or not, we cannot give guarantee here. For ANSI style, we can give guarantee. It is portable. Okay. So equijan is over. So tomorrow I explain outer Jan. In the outer Jan, subtypes are there like left outer, right outer, full outer. We discuss in the next session. Okay. Thank you everyone. See you tomorrow.